When talking about the algebra of functions, we're going to be looking at adding, subtracting, multiplying, dividing, and then in the next video I'll actually start talking about composition. So when we're talking about the algebra of functions, we are talking about, the sum function, the difference, the product, the quotient. For any two functions, f and g, the sum function can be found by adding the functions f and g together. This sum function can be found taking f minus g, etc., etc. Something we'll have to look out for when we're dealing with the quotient function is division by 0. And so we will have to, from the quotient function, limit any x value from the domain that would cause our denominator to equal 0. So looking at some examples, so for f of x equals x squared plus 2x and g of x equals x plus 2, we want to find f plus g of x. So we read that f plus g of x. And that notation, when you see that notation, this notation asks us to find the sum function. Okay, this references the sum function. And to find the sum function, we can add, like we said here, if we want to find this sum function, we have to add f and g together. Okay? So for this f and for this g, we want to find the sum function. So we have, to find our sum function, we have to add our functions together. And so f of x, we have x squared plus 2x plus g of x, which is x plus 2. Okay? So we are basically now, this is just the addition of two polynomials. And to add polynomials, all we have to do is combine like terms. So we end up with x squared, 2x plus x is plus 3x plus 2. Okay? When you're dealing with the addition of two polynomials, the parentheses really are just there for looks. They have no mathematical significance. If you're more comfortable, you can go ahead and rewrite it, just as this is the same as x squared plus 2x plus x plus 2. And combining like terms, then you get the same x squared plus 3x plus 2. So adding f and g together results in this sum function. Okay? Here, for the same f and g, I want us to find f minus g of 2. So in the previous example, when we have this x here, it's saying find the function. Okay? In this example, we have a 2. So if we have a number rather than an x, then that notation wants us to evaluate the difference function. Okay? So to find f minus g of 2, I need to evaluate the difference function for an x value of 2. And I have a couple options that I can use. If I want, I can find what the difference function is and then evaluate it to find this value. I can also evaluate each function and find the difference. So let's talk about option 1. So option 1, we would first find the difference function, which is f minus g of x. And to find f minus g of x, I have to subtract f of x minus g of x. So that would be, so here's my f of x, so that is x squared plus 2x minus my g of x, which is x plus 2. When we're doing a subtraction of polynomials, it is important that we subtract every term in the second polynomial. So I have to subtract the x and I have to subtract the 2. So this would be x squared plus 2x minus x minus 2. Combining like terms, we get that our difference function, our f minus g, is x squared plus x minus 2. And now that I have found the difference function, now to find f minus g of 2, which is what I need to find ultimately, I can substitute 2 into this difference function to do that evaluation. So therefore, f minus g of 2 would be 2 squared plus 2 minus 2, which is 4. So the answer here is 4. And when you're doing your homework, a lot of the questions are multi-part questions. So, part A, they may ask you to find the difference function, and in part B, they may ask you to evaluate. So when you're doing your homework, if they've already asked at some point for you to find the difference function, then it seems reasonable to go ahead and just substitute into that function that you've already found. If you haven't already found it, this is way more work than you would really need to do in order to answer this question. So if along the way, if somebody hadn't already asked you to find the difference function, I would say, probably a better bet is to just evaluate each function and then find the difference. F minus g of 2 is the same as f of 2 minus g of 2. Using that rule on the first slide, just replacing those x's with 2's. And so I can evaluate this by finding the value of f of 2, finding the value of g of 2, and then doing that subtraction. So to find f of 2, I have to substitute 2 into f. So doing that, I'm just going to put it up here where I have all my work. Let me change my ink color. Go red. So f of 2 is 2 squared plus 2 times 2. So 4 plus 4, that is 8. So f of 2 is 8. G of 2, so I'm going to substitute 2 into g. That is 2 plus 2. And 2 plus 2 is 4. So we have to do 8 minus 4. And 8 minus 4, we get the same answer using either method. Quotient function, so if we want to find f over g of x, you can do so, whoops, that's upside down. You can do so, what this says, by taking f over g of x is f of x divided by g of x as long as g of x does not equal 0. Okay, so f of x over g of x is what we need to do to find this quotient function. And so my f of x, we're just using the same f and g. I just did that for ease. Of course, your functions are going to vary. I was just sticking with the same one. So here we're going to have x squared plus 2x divided by x plus 2. When you are working with trying to find the quotient function, you should always give a simplified function. And if you can go back, you simplify, this is a rational expression or a rational function. And if you're going to be simplifying, you need to do so just like you would if you were reducing a fraction. Okay? If you have a numeric fraction like 4 over 6, that fraction can reduce because 4 and 6 both have a common factor of 2. Right? 4 is 2 times 2, 6 is 2 times 3, and so we can cancel that common factor and give us the reduction of 2/3. It works the same way here. to reduce a fraction requires you have a common factor. And so if you want to reduce, you can only do so if you have both numerator and denominator in factored form. Okay? So you need both numerator and denominator in factored form in order to reduce. Okay, you cannot just cancel a term with a term. It doesn't work that way. It has to be factor and a factor. So in the numerator, x squared plus 2x, these terms have a common factor of x. So if I factor out the x, I have x times x plus 2 all over x plus 2. Now, both numerator and denominator, right, the bottom didn't factor, so this whole thing is a factor. Both numerator and denominator have a factor of x plus 2. So just like up here, they both had a factor of 2, which I could cancel. And what I'm left with is then just x. So my quotient function, f over g of x, is x. Though remember, as long as the bottom function, g of x, does not equal 0. Okay? So if you look at your function g of x equals x plus 2. Is there a number you can put in for x so that the value of g equals 0? Yes, that would be negative 2. Right? If x equals negative 2, the denominator equals 0. And the issue with the denominator equaling 0 is that division by 0 is undefined. So when I'm working with quotient functions, I can't just say that f over g of x equals x. I have to add in the extra condition, that is, as long as x does not equal, in this case, negative 2, right? Because this makes our g of x equal 0. And we don't want our g to equal 0. We don't want our bottom function to equal 0 because division by 0 is undefined. Okay? If I were to ask you to evaluate f over g of negative 2, you would have to tell me that that's undefined. Okay? This function cannot be used to evaluate f over g of negative 2. If you plug that in and you say, oh, it's negative 2, it's false. Okay? If x is negative 2, this quotient function is undefined. For all other values of x, you can evaluate using this quotient function. So again, same f and g. We want to find the product. So that's times f times g of 3. So again, you have your options. You can first, if you want, you can find the product function, which is f times g of x. So to find f times g of x, we would multiply our two functions together. So f of x, we have x squared plus 2x times g of x is x plus 2. So to do this multiplication, we're multiplying two binomials. So if I'm multiplying two binomials, I must FOIL. So first times first, that is x to the third. Outer times outer, that's plus 2x squared. Inner times inner, plus 2x squared. And last times last, we have plus 4x. Simplifying, because these are like terms, gives us x to the third plus 4x squared plus 4x. So this is our product function. And now that we have the product function, we can find this f times g of 3 by substituting that value of 3 into the given function. So f times g of 3 then is 3 to the third plus 4 times 3 squared plus 4 times 3. So what does that give? You might want to grab the calculator. That's 27 plus 4 times 9, that would be 36, plus 12. And so if we add 27, 36, and 12, we end up with a sum of 75. So using this long drawn out method, we found that f times g of 3 is 75. Option 2, however, we can evaluate f times g of 3 simply by finding the value of f of 3 and multiplying it by the value of g of 3. So to find f of 3 again, we're going to substitute 3 into f. So f of 3 is 3 squared plus 2 times 3, and 9 plus 6, that's 15. So f of 3 is 15. G of 3, we've got 3 plus 2, and that's 5. So 15 times 5, we get 75 doing it that way as well. Okay, so regardless of the method, you should get the same output. You should get the same answer when you are, whether you do it this way, which I find easier, or if you do it this way. I just be careful, because obviously when you're doing all this FOILing and you're working with a lot of variable terms, you kind of have a lot more margin for error. There's a lot more places you can mess up. So here we want to find f over g of 7. Or we want to evaluate the quotient function for a value of x equals 7. So if I do option 1, that involves finding the quotient function. So f over g of x is f of x divided by g of x, or x squared minus 3x minus 28 all over x squared minus x minus 42. But like we were saying before, then we always want to see if we can simplify when we're dealing with a rational function. And to simplify, you can only simplify if both numerator and denominator have a common factor. So both have to be in factored form. The numerator we can factor into x minus 7 times x plus 4, and the denominator factors to x minus 7 times x plus 6. And we do see that numerator and denominator have a common factor, and that is the x minus 7. So my quotient function is x plus 4 over x plus 6, as long as x does not equal any number that makes g of x equals 0. So it's easiest when trying to decide what numbers need to be excluded from the domain, it's easiest to look at when your denominator is in factored form. The factorization for our function g, x squared minus x minus 42, is x minus 7 times x plus 6. And so the values that make that, any number that makes either factor equal 0, will make this product equal 0, and hence will make the denominator equal 0. So based on that, 7 minus 7 would equal 0, so I know that 7 must be excluded from my domain. Also, negative 6 plus 6 would equal 0, so negative 6 would be excluded from my domain. Okay, so here, notice that this number is what they're asking me to evaluate. And as I was saying before, so this function is undefined for either an x value of 7 or negative 6. You cannot substitute 7 into this function here. That's what this is saying. So the answer is, this is undefined. Okay, if the number I was giving you here was any number other than 7 or negative 6, it would be perfectly acceptable then to substitute it into this function and evaluate from there. But for any number that makes the denominator equal 0, that's going to be undefined. And not the denominator of the simplified function, but the denominator of the bottom function g, or whatever the bottom function is in your different example. The second option, don't forget, we can, to find f over g of 7, we can do f of 7 divided by g of 7. So when looking at those values, if you substitute 7 into f, we have f of 7 equals 7 squared minus 3 times 7 minus 28. So that's what? 49 minus 21 minus 28. That would be 0. If we substitute 7 into g, we already know that that's going to be 0, but we can go ahead and go with it. So that would be 7 squared minus 7 minus 42, and 49 minus 7 minus 42, that is also 0. And what the 0 in the top is not important. What really guides us is this 0 in the denominator. Okay, so if this had been any number divided by 0, it is going to be undefined, right? Any number divided by 0 is undefined. So we get the same thing either way. So if you're using option 1, it's very important that you not only find the function, but that you also find the numbers that have to be excluded from the domain, so that you don't try to take these values and substitute them into the function and come up with the wrong answer for that x value. Okay? Alright, composition of functions. That's next. To be continued.